Hello again, and we are now on the part 3 of our lecture, which involved the problem solving that we encounter throughout the lecture of part 1 and part 2. Now, let's first solve this equation, this problem, the writing of equilibrium or acid-base equation regarding about Bronsted and Lowry. Now, this slide here is slide number 21 on PowerPoint number 1, and let's now solve this. Now, the question here says, write the equation for the ionization of nitric acid in water. Sorry. Ionization of nitric acid in water. Nitric acid in water. Okay, ano ba ang mangyayari dito? Now, since sabi dun sa may problem letter A natin, nitric acid plus water. So, HNO3 plus H2O. Now, in order to write the acid-base equation here, is alamin ninyo kung nasan yung acid natin and nasaan yung base natin. Now, ano ba yung acid and base natin? Now, yung kwan natin dito, yung listahan ng mga strong acid, strong base natin, ay naka-indicate dito sa PowerPoint natin. Sir, nasan po ba yon? Okay. Siya ay nasa slide number 43, and for the list of strong bases, naka-indicate siya dun sa my slide number 44. Okay. Now, I will require you to memorize this one kasi magagamit nyo siya throughout our module. And paano ba natin makakanto? These are the list of strong acids na kung saan is ito. And then the rest, yung hindi nakalista dito, sila yung mga weak acid. And also, ito yung listahan ng ating mga strong bases, yung mga hindi nakalista dito. Sila yung mga weak bases natin. Okay, now let's go back. Now, ano ba itong HNO3 natin? Is it acid or a base? Now, nitric acid, from the word itself, syempre, this one is an acid. And therefore, yung water natin, since siya daw ay magaling mag-adjust, magaling naman daw siya mag-adjust, so magpaparaya na siya. Siya na daw yung base natin. Now, yung nitric acid kasi natin, since base, ano mang definition ni Bronsted-Lowry, siya ay proton donor. Proton donor. So, therefore, i-give up niya yung proton niya dun kay hydrogen. Siya ngayon ay magiging nitrate negative. Nitrate negative. Bakit ba siya naging negative? Sir, paano ko nagkaroon ng negative sign doon? Kasi nga, yung ating proton is a positively charged and itong nitric acid natin sa full is neutral. So, nabuwasan siya ng positive charge. So, 0 minus 1, that is negative 1. Plus, since nag-donate siya dun sa may water natin, 2 plus 1H, that is H3O. And then, from neutral, plus 1, 0 plus 1, that is positive. And that is for letter A. Okay, sa may letter B naman daw, identify the conjugate acid-base pairs in equation for part A. Now, madali lang naman ito is first, ano ba yung reactant natin na nitric acid? Is an acid. So therefore, ang product niya kabaliktaran is automatically a conjugate base, where C stands for conjugate, and yung base naman natin, ano mang kabaliktaran ng base, that is acid. So therefore, this one is the conjugate acid. So that's it. Wow, ang dali, di ba? Okay, kayang-kaya na yan. Sige. Now for part C, what is the conjugate base of phosphoric acid? Ano daw yung conjugate base ng phosphoric acid natin? What is the conjugate base? Okay, sir, what is the concept of conjugate base po ba? When we say conjugate base, it involves the reduction or minusing or removing the hydrogen ion in the compound. So therefore, from H3, siya ay magiging H2 PO4. Now, as stated earlier, yung nabawasan siya ng proton from neutral as a full compound, siya ay magkagiging na negatively charged. And that is the conjugate base for phosphoric acid, H2PO4 negative. Now, for letter D, ano daw yung conjugate acid ng sulfate ion natin? Ano daw yung conjugate acid? Okay. Ano kaya? Okay, since conjugate acid, it only involves an addition of hydrogen ion. So, mangyayari lang dito is HSO4. Dagdagan mo lang ng H. Pero sir, ano po magiging negative charge niya? Ano po magiging charge niya? Since proton, ang dinagnan natin, which is positively charged, so negative 2 plus 1 equals negative 1. So HSO4 is equals to negative. Sir, bakit hindi po nakasulat yung 1? Kasi nga sa may algebra natin, hindi naman natin sinusulat yung 1. And that's how you solve the problem for PowerPoint 1, slide number 21. Okay, is there any questions, clarifications so far? Siyempre, wala. Hindi naman kaya mapagtanong dito. Online class to eh. Okay. Now, let's undo what I've done here. Let's clear the board. Let's clear the board. Let's clear the board here. Okay. Now, for another part, punta na tayo sa may pH and pOH calculation. Dito, since naaral naman na ito sa mid-gen chem ninyo, I'll give you an exercise that involves ang calculation of pH, pOH, hydronium ion concentration, and hydroxide ion, and pKaW. That will be your assignment for Module 1, besides from the pre-lab and your post-lab activity. Now, let's go on to our second problem, which is the calculating the acid dissociation constant from the pH. Yes. Okay. So this one is from the PowerPoint number 1, slide number 49. I will paste it to the pink and let's solve the following equation. Now, how do we solve a mathematical problem in chemistry? Now, first and foremost, guys, alam niyo naman ito since naaral niyo naman ito, is identify first the given. What are the given? Okay, the given are the concentration of formic acid is equals to the ilan daw? 0.10 molar. Tapos yung pH natin, ilan daw ulit? Siya ay 2.38. And ano yung hinahanap sa problem natin? Ang hinahanap doon is yung Ka. Okay. Ano ba yung formulang gagamitin natin dito in order to solve Ka? Ka daw, based on the formula, is the concentration of the hydronium ion plus the acetate or formic ion all over the concentration of formic acid. Sir, saan po nanggaling yung formula na yan? Okay, since ang equation kasi natin nanggaling siya dito from the ionization of formic acid plus water, lagi ninyong ilalagay yan, from the equilibrium, which is H or formic ion plus hydronium ion. And sinabi natin kanina, when expressing an equilibrium constant, it is always product all over reactant. Now, using this formula here, paano ba natin magagamit? Ayan. Substitute the known values is step 3 when solving a mathematical problem in chemistry. You now have a value for formic acid, which is 0.10 molar. And wala yung hydronium ion natin. Now guys, take note, this one here, it involves an equilibrium calculation. So therefore, the initial concentration will not be counted. At gagamit tayo dito ng ICE. Yes, you heard it right, ICE. Now dito sa may pH natin, ano ba ang mag-obtain natin dito sa may pH natin? We can obtain the concentration of hydrogen ion, which only 10 raised to negative pH. So therefore, 10 raised to negative 2.38. 2.38. Wow! Paano ba natin isa-solve yan? Unang-una, gumamit ka ng calculator. Kung kaya mo na may calculate yan, sige. Ayan. And voila, meron ka ng sagot na 4.16 times 10 raised to negative 3. Which involves, pag sinabi natin ito, when we say pH, this is the concentration of the hydrogen ion or the hydronium ion, I shall say, doon sa ating equilibrium constant natin. So insert lang natin at initial, 0.1. This one is 0 and this one is 0. And dito naman, is mag-add tayo ng 4.16 times 10 raised to negative 3. Sorry, that's not 1, but rather a negative. And this one, since plus, this is 4.16 times 10 raised to negative 3 and plus 4.16 times 10 raised to negative 3. Yan. That's it. And then, pag minusin nyo, you will obtain 0.1 minus 4.16 times 10 raised to negative 3. That is 0.09584. Tapos 4.16 times 10 raised to negative 3 and 4.16 times 10 raised to negative 3. So how do we can? Meron tayong values dito in order to calculate KA. Now substitute the known values for KA. So KA, pasensya na magulo yung whiteboard ko guys. So 4.16 times 10 raised to negative 3 times 4.16 times 10 raised to negative 3 all over 0.09584 parentheses is equals to ilan daw ang equals niya. Using your calculator, guys, sa module 1 natin, nagamit kayo ng calculator lagi kasi it involves sa calculation. And ang magiging sagot natin is 1.8 times 10 raised to negative 4. And this is now the acid dissociation constant for formic acid. That's how you solve the problem. Take a screenshot na lang, guys, so that we can proceed to another. Okay. Okay, next problem. Punta naman tayo sa problem with regards doon sa may buffer natin. I will open the file first. And okay. Now let's solve the problem in PowerPoint number 2, slide number 18. PowerPoint number 2, slide number 18. Okay. First and foremost, ang gagawin natin dito is identify the given. Identify the given. So given natin dito, here, is the concentration of sodium lactate. Ilalagay ko na lang guys na lactate, which is 0.10 molar. And yung concentration ng lactic acid is 0.12 molar. 0.12 molar. Okay. And then, meron daw tayong Ka value na 1.4 times 10 raised to negative 4. Ang hinahanap sa may problem, ano daw yung pH niya? Okay, second step sa mathematical problem solving is identify the formula. Isa lang naman yung formula natin sa may buffer, which is the Henderson-Hasselbalch equation, which given by pH is equals to pKa plus log times the concentration of the conjugate base all over the acid. Now, guys, pagpasensya ninyo yung sulat ko kasi medyo nahirapan din ako. Sa mga nakakilala sa akin dito, yung mga naging estudyante ko last time, alam niyo naman kung paano yung sulat ko. Okay, next is first, now, ang gagawin na natin dito is substitute the known values. Sir, ano po ba yung pKa? It's simply just a log Ka. It's just a log Ka. Now, substituting negative log Ka, which is 1.4 times 10 raised to negative 4, plus logarithm of the concentration conjugate base, which is 0.10 molar here, tapos 0.12 molar, yan, using your calculator, syempre. Okay. Ida-direct calculation ko na lang siya, guys, since kayang-kaya na naman. Ayan. Yan. Direct calculation na tayo. And voila! Meron na tayong sagot, which is 3.77. So, therefore, The pH of a buffer of 0.12 molar lactic acid in sodium lactate is 3.77. That's how you solve this problem. I-take na lang na screenshot, guys, kasi we will move on to the next problem. Okay, let's proceed again. Proceed na tayo para mabilis. Now, I will skip this part here because this will be your exercise or assignment at your home, homework ninyo, next solve ninyo, which will later you turn into me on or before Friday. Now, punta naman tayo, what if mag-add tayo ng acid or base sa may buffer natin? As we discussed earlier, di ba, that when we add a certain amount of acid or base is makaka-affect or mag-change yung pH ng buffer natin kahit gaano pa kataas yung buffering capacity niya kapag hindi na nakinaya. Kasi nga lahat naman may hangganan, di ba? So, ayun, punta tayo ngayon dito. Okay, calculating the pH changes in buffer. Okay, sabi dito sa may problem na to, which is slide number 24, PowerPoint number 2, a buffer is made by adding 0.3 moles of, it's not a lactate. Okay, HC2, H3O2, which is a Ka value of 1.8 times 10 raised to negative 5, and 0.3 mole of sodium, C2H3O2, to enough water to make a 1 liter of solution. Now, ang pH daw niya is 4.74. Now, for our problem here, calculate the pH of this solution after 0.0.2 mole is added. Now, for problem letter A here, sorry for that. Nope. Wait lang. Okay. Okay. Now, for letter A, syempre, since pH, we will use the Henderson-Hasselbalch equation. Na-direct na tayo dun sa may formula, mag-shortcut na tayo, and hindi na tayo pupunta doon sa may given na part since nandito naman na siya na-present doon sa may slides. Wait, nag-screen sharing ba? Patay tayo dyan. Okay. Okay, letter A. Now, pH here is equals to, syempre, sulat nyo lang din yung formula, pKa plus log of concentration of conjugate base all over acid or weak acid here. Now, dito kasi, sa may part A natin, is ano bang inad natin? What is sodium hydroxide? Nag-add daw tayo ng base. So, therefore, yung based from the principle na na-discuss natin earlier, sa may last lecture natin, is manadagdagan yung concentration ng conjugate base natin and mababawasan yung concentration ng acid natin. Kasi once nag-add ka ng base. Now here, ito, hindi example ko lang to guys. So the numerical value for this is 0.02 moles and 0.02 moles. Now let's answer the following question. Now, pKa here, or wait, pKa or teknan tayo sa may negative log. Negative log of 1.8 times 10 raised to negative 5 plus logarithm of ano yung value? 0.3 plus 0.02 quantity all over 0.3 minus, that is minus, I'm so sorry, 0.02. Now, magdadirect computation na tayo here, and their answer should be log of 0.3 plus 0.02 over 0.3 minus 0.02. And voila, you'll have the answer, which is 4.80. That's it. Now take a screenshot And we will proceed to letter B. Now for letter B, same process, but we add an acid here since hydrochloric acid is added. Ang mangyayari naman dito is mababaliktad naman dito, guys, is based from the equation here, mababaliktad naman siya. Okay, let's write the Henderson-Hasselbalch equation, pH plus pKa plus log of conjugate base all over acid or weak acid. Ay, ang mangyayari dito is, ito yung madadagdagan, ito yung mababawasan. So, let's have it again. Okay, solving. Negative log 4.8, 1.8 times 10 raised to negative 5 plus log, what is the numerical value of conjugate base? That is 0.3 minus 0.02. Sir, bakit 0.02? Kasi yun yung nakasaad sa problem. And then, all over 0.3 plus 0.02. And guys, take note that ito ay as a whole. So, ayan. And solving for the equation, we will yield an answer of direct computation na tayo, guys. We'll have an answer of 4.68. That's the pH. Uy, sir, tama po ba yung pinaggagawa nyo? Siyempre, checkin natin yan. Tingnan natin. Letter A. Okay. Uy, tumama, di ba? O, sige. O, yun lang. Ba't yun yung sinunod? So, ayun na yun. Then, for our sample exercise here, which is preparing a buffer, paano ba tayo mag-prepare ng buffer dito? Now, this involves a derivation of formula here. Now, guys, take a screenshot of this one and so that we can proceed to our next problem. Now, I assume that you're done, Let's save here. Okay. Now, for this problem, guys, is sabi dito, how many grams of ammonium chloride must be added to 2.0 liter of ammonia solution to form a vapor whose pH is 9.00? Assume that the addition of ammonium chloride does not change the volume of the solution where Kb is equals to 1.8 times 10. Now dito, gagamit kayo ng another form of Henderson-Hasselbalch equation, which is the POH is equals to PKB plus log. Kung kanina is conjugate base yun, dito gagamit tayo ng conjugate acid all over conjugate, that's not weak base. Okay, paano ba natin ma-solve yan? Now, tinatanong kasi dito, based from dun sa may given natin, ang hinahanap dito is yung mass ng ammonium chloride. Okay, sorry at nag-direct na ako sa formula. Okay, now dito, paano ba natin ma-solve yung mass ng ammonium chloride? Sir, wala naman po dito yun. Ano ba yung ammonium chloride natin? That is the conjugate acid. Concentration. Now, the concentration that na-discuss ninyo last semester, which is analytical, this concentration here was expressed in terms of molarity or moles per liter. So therefore, ano bang formula ng molarity natin when we expand this equation? That is mass all over the molecular weight of the substance all over liter of the solution. And we are looking for mass. Ngayon, ang hanapin muna natin, guys, is yung molarity ng acid. Kasi ito, given na ito, and given na ito, which is 2 liter, and the formula weight or molecular weight of the ammonium chloride. Now, let's solve. But first, mag-derive muna tayo. Mag-derive tayo ng konti. Okay. Now, transposing to the other side of PKB, which yield to positive, from positive to negative, which is PKB. So, ang maditira dito is log of conjugate acid all over base. Now, how do we cancel the log? Now, gagamit tayo sa may log logarithm, which is 10 raised to POH minus PKB. Sorry guys, that is PKB is equals to conjugate acid all over base. Now, using criss-cross multiplication, we will now have a formula for the acid here. So therefore, the concentration of conjugate acid will be the multiplication or product of the concentration of base times the 10 raised to POH minus PKB. Okay, ano ba concentration ng base natin? Ilan daw? 0.10 molar ng ammonia. Then 10 raised to, ano ba yung POH natin? Sir, pH naman po yung nakalagay dito. Okay, diba, naituro naman na yan, which is pH plus POH is equals to 14. So, minus 14 daw, so magiging 5 yan. 5. Sir, ano naman po yung PKB? Okay, PKB is just a negative log of KB. Sir, wala naman pong value ng KB dito. Meron. Ayun, nasa may dulo. And ang magiging kwan nito, guys, is maging value niya is pagka ni-negative log niya siya, mag-yield siya ng numerical value of 4.74. So, therefore, this will be 4.74. Now, solving this problem here will yield 0.10 times 10 raised to 5 minus 4.74. Magkaaroon tayo ng 0.18. 1819 moles per liter. Hindi pa ito yung final answer. Kasi nga, we are looking for the mass. O how many comes to chloride. Now, dito na tayo babalik sa may formula na ito. So, which is, nakuha na natin yung molarity. So, therefore, the molecular weight and times per liter. So, the mass of ammonium chloride here is equals to the molarity. Ilan ba yung molarity times the molecular weight or formula weight times liter. Ilan yung molarity natin? 0.1819. I will drop the unit na moles per liter. And then, ano ba yung molecular weight ng ammonium chloride natin? Okay, the ammonium chloride molecular weight is just the addition of the atomic weights of ammonium chloride. I-discuss pa ba? O, sige. Okay, summation lang ng atomic weight ng N, ng H, and ng chlorine. So, nitrogen has 14, and hydrogen has 1 times 4, and chlorine has 35.457. Wow, memorize ni sir. Hindi. Kwan yan. Lagi kasi siyang ginagamit. Kaya medyo natatandaan ko siya. So, ang molecular weight daw natin is 53.457 grams per mole. Sir, ano po yung volume? Okay, nakalagay din dyan, which is 2.0 liter. Now, direct computation here, liter, cancel, moles and moles, and matitira grams. So therefore, the mass of ammonium chloride required to prepare a buffer that has a pH of 7 is 1819 times 53.457 plus 2.0 liter. Ang kailangan nyo daw is 19.447 grams of ammonium chloride to prepare a buffer with ammonia whose pH is number 9. And that ends our discussion for part 3 of our lecture of module 1. That's it, and have a nice day, guys.